So everybody knows those really useful 0.96 inch OLED screens, OLED displays. They're really nice but tiny. So I bought one of those 1.54 ones, which are actually really nice, really big. However, out of the box they can only do SPI. And as I found it quite complicated to change that to I2C, I made this video. On that 1.54 inch display, there are a couple of things that have to be changed, or some things are different. So first of all, two soldering changes have to be done on the backside. Then there is a different I2C address compared to the 0.96 inch display, and two additional components are needed on that side as well. So I'll show you how to do it. So if you look at this picture that I made, you see that I have to change one resistor, the one from SPI, which is a 4.2 kilo ohm, 4.7 kilo ohm resistor, needs to be moved to the I2C interface, and the one that is being numbered R4 needs to be bridged with a 0 ohm resistor, basically shortened. So I'm going to switch this resistor to here and include the 0 ohm resistor here. So I included the short here. You can see 0, and I moved that resistor from SPI to I2C. Now for the wires. You can see in the schematics there are 4 wires, basically ground, VCC, which is 3.3 volts, the data as well as the clock wire for I2C. How I do it. So I prepared a few wires. Now I have another 4.7K resistor, which I'm going to place between DC, which I connected to plus to reset, so last but not least, I've chosen a tantalum capacitor just because I had it in my portfolio. Any capacitor will do. We just have to basically put the capacitor between ground and reset in order to define to get a defined reset once we switch it on. So therefore I flip it over again, and the resistor, the capacitor, please make sure that you put the polarity in the right way. Alright, flip it over once again and cut the surplus wires away. As you can see, the the 4.2 kilo ohm resistor between res and DC is also nicely soldered. Alright, that's it. So, last step, the display. I braided the wires, connected them to a nice plug that fits in here, and as you can see, plus VCC, data, clock and ground, which kind of corresponds to here, which is the Raspberry Pi I/O header. So, and if I now connect it to that little connector there, of course it stays black. Now, first of all, I'd like to show you what I did on the software side. Sorry for that old school, I found it much easier to do it that way. I use an from B library, the OLED 96 library. It is, as you can see, 3 years or even 6 years old, so there are not too many activities on it anymore. However, the nice part is it runs off of, let's in the end, the example and the TrueType fonts, and that's it. But start off, let's see if we see it in our I2C. On Raspberry Pi, you see there is a nice command called I2C detect, and if you run it, and it is really good connected, it shows up on which address this display is being connected. So as you can see, it shows up in there. And now let's go for the Python code. I used the example 2, and example 2 is what this OLED can do. This wave is actually because of the refresh rate, so that's a camera artifact. And that's all. So as you can see, it runs on the first time, and that was it. There's of course also the example 1, which is just in hello world. Tuck, there it is.